So hello, it's my pleasure to invite Nele Renders on stage. Nele is coordinator of the streamSAVE project and works as an expert on energy policy and evaluation at the Belgian Research Institute VITO, having more than 15 years of experience on providing support to the EU and its member states. Nele, I will stop sharing my screen and you can then share yours.
Good afternoon, everyone. It's good to see welcome in this webinar, and also thank you for the presenters for their willingness to present here today. I will shortly introduce you to the project, which is streamSAVE, but therefore I will first start sharing my screen. Voilà. Wait a bit on presenters mode. Yeah. So streamSAVE is an Horizon project that started in September 2020 and will still run until summer of this year. And there are multiple organizations involved, 12 in total, scattered across research and policy institutions, energy agencies, and institutions or organizations closer to the market, such as the Cooper Institute. And in short, we provide capacity support to public authorities on Article 3 and 7, which will be in future Article 4 and 8 of the Energy Efficiency Directive. And we do so by creating an open dialogue, more specifically on calculation methodologies or deemed savings methods, and try to streamline these across countries, while we acknowledge the differences between member states as well in estimating the savings of specific actions. And within streamSAVE, we focus on priority actions, 10 in total, and priority actions are actions which we consider as still relevant in terms of energy savings, so highly relevant within that respect, but also considered as a priority issue by national public authorities. So therefore, getting input from stakeholders, etc., is very important to us. We do not only provide calculation methodologies to estimate savings, but we also give more information on how to estimate cost effectiveness for those actions. And by providing the support in multiple countries, the aim is to realize additional energy savings in the upcoming years, which is, of course, in the given context, still very even more relevant than it already was. And how do we realize these objectives in practice? So what is the project dealing with? As said, we focus on priority actions, 10 in total, and at the top of this graph, you see the first round of priority actions which we dealt with, which was heat recovery, bugs, refrigeration systems, electric vehicles, and lighting systems. And halfway the project, about February of last year, we provided also support on an extra five actions, namely renewable heating, energy poverty, electric motors, which will be discussed today, of course, how behavioral changes can reduce energy consumption, and as last one, also modal shift, but focused on freight transport. So that is the list of our 10 priority actions for which we give support in multiple ways. More specifically, we discuss existing and standardized saving methodologies in the peer-to-peer dialogues, which is in the middle of the slide. We also provide capacity support to the 10 partner countries within our covered by our consortium. And most importantly, and what is also discussed here today, in the knowledge facility, so at the left, we constructed, or we build up a guidance on standardized saving methodologies, where for each priority action, those methods are described together with indicative values on for these to estimate the savings based on these formulas, and these formulas do not only give you a result in terms of energy savings but also CO2 and in relation to costs, and those methodologies take also into account the aspects that are relevant, of course, specifically for Article 3 and 7 of the EED. If you want to learn more, or even if you want to test those methodologies in practice, you can do so by looking into our streamSAVE platform, which we built, and you can register for that by following the link, which you can find at the bottom of the screen. So that is, in short, how we deal in practice. With our support throughout streamSAVE. And as said at the beginning of my presentation, what for us is important is getting the feedback of our stakeholders to make sure that we address the needs as good as possible. And therefore, at this moment, we are also running a feedback survey for which you can give suggestions on how the project went so far and can run in future, but also specifically on how we can valorize streamSAVE on the longer term. So also beyond our project, and that you can do so by completing the online survey, for which you can find the link below and which I will also put in the chat. You can, and it is a very short survey, so happy to hear your suggestions of where streamSAVE can also be of added value. And that was my short introduction. Thanks once again for joining this webinar, and also to the other presenters. Interesting to hear their story as well on this subject.
Excellent. Thanks a lot, Nele, for being so concise again and giving this overview of streamSAVE. And I think people stole your thunder by putting the links already in the chat, so you even don't have to go to the chat anymore.
Great.
And indeed, people, so the chat window is activated. My apologies, it was a setting that was wrongly put. Okay, so next up is Margot Pinot, well known to many of you, I guess, as she's been at the European Commission for many, many years. And today she leads the team on energy efficiency policy development in the unit B2 at DG Energy. She will set the scene by providing us with an overview of the provisions in the Energy Efficiency Directive that are focused on promoting energy performance contracting. So, Margot, I will start sharing my screen.
Thank you, Rüdiger. Thank you very much for introducing me and for inviting me. And good afternoon to everybody. I'm very happy to participate in this interesting webinar, and thank you for the organization. It is very good connection of topics about methodologies for estimation of savings and use savings, and how it can promote ESCOs and energy performance contracting models. So a good idea for a webinar, and I'm very curious to hear the discussion today. So we can maybe move to the next slide, where I will be presenting the overall policy background and context. But as introduced, I will focus more on the revision of the Energy Efficiency Directive that is currently ongoing, and the process which I'm leading now, and on the provisions that are related to ESCOs. And also I will put some focus on Article 8, as this is, I would say, the core article for this project, according to my understanding. Setting up the context, geopolitical context and market context for energy sector is very difficult, as you all know, but it is creating some acceleration. I mean, it's urging us to accelerate the clean energy transition, obviously, because in addition to the climate goals, we have also the objectives of reaching the independence from imports of Russian fossil fuels by 2027. And this is really a very, very short timeline when we need to reach this independence. And it is totally aligned with our long-term objectives, so the clean energy transition. And of course, energy savings, reduction of demand, and energy efficiency play a very important role in a short and long term. So maybe in the next slide, it is an overview of what the Commission and the co-legislators did at glance last year. It is quite impressive number of legislative acts and policy initiatives to tackle the crisis. And I must say that, yes, our Director General work without any break to deliver all of this. Many of these measures, of course, focus on gas and gas demand reduction on gas markets, but also because, as you know, electricity production is very much linked to gas, and the prices are set according to gas fired generation. Therefore, also electricity was targeted, and as said, energy savings and demand reduction in various dimensions in this context. So in the next slide, I just wanted to highlight this overarching strategy, which is called Repower EU, and that the Commission, through this strategy, put an accent on energy savings and energy efficiency, diversification of our energy suppliers, and acceleration of investment in renewables. And these three pillars will serve us to reach the independence from imports of Russian fossil fuels by 2027. That's the objective. So this Repower EU communication was issued in May last year. And among others, it also set a new target for energy efficiency. I mean, the Commission proposed a new target that is now incorporated into the negotiations of the revision of the Energy Efficiency Directive. So in the next slide, yeah, a few words more about energy savings. So actions that are within the Repower EU plan that are undertaken by the European Union and European Union member states. The communication Repower EU included EU Safe Energy Plan to guide and coordinate member states' actions in cutting energy consumption. It was followed, the Repower was followed by gas demand reduction plan with the target of 15% gas reduction by next spring. Then the following measure tackling the peaking electricity prices in the wholesale market, aimed at reducing the peak price hours, so reducing the peak demand of electricity by at least 5%, and this is an obligation, not a target. And in addition, a target for member states to reduce the overall electricity demand by at least 10%. So in addition to what we have as energy efficiency targets, you see that there is a lot of focus on targeting reduction of demand and energy savings across the EU legislation now. In the next slide, as said, this short-term actions in reduction of demand and saving energy should be accompanied by a longer-term measures, and for this, energy efficiency is the right investment and the right measure to take. And Energy Efficiency Directive will be setting the regulatory framework to ensure that these efforts are lasting, that these savings, they are not just short-term behavioral change that will not last, but that will really invest in something that will structurally reduce energy use. And on the legislative side, this also materialized by proposing a higher target for 2030 for energy efficiency. So as you know, probably in the 54-55 package, the EED revision proposed 9% target for 2030 based on 2020 baseline. And the Repower EU added this new challenge of phasing out fossil fuels by 2027, which requires an additional effort, and that's why 13% target is proposed through Repower EU to be in the EED Article 4. So this also has been modeled at macroeconomic level, and since we are living now in a totally different market conditions and the prices are much higher, this 13% target also is considered as economically and technically feasible, cost effective. So maybe the next slide, that will be, I think, everything as regards the general context, and now regarding Energy Efficiency Directive revision. So as said, it was part of the Fit for 55 package that the Commission adopted a number of legislative proposals on the 15th of July 2021. In this proposal that is now going through the normal negotiation legislative process, so it is now discussed between the co-legislators, the Parliament and the Council in the so-called trilogues. Yeah, I cannot tell you the date when this process will finish, but we are already quite well advanced, and hopefully soon we'll have an agreement, a deal on the final how finally the legislation, the revision of legislation will look. So it's a recast directive. It means that it is more thorough revision. There will be new numbering. That's why, as mentioned in the introduction, we are going from Article 3 to Article 4 as regards the article that is focusing on targets, and from Article 7 to 8 as regards the article that is focusing on energy savings obligation. And that's the action of the recast, that it is entirely revised and renumbered. Regarding the target, as said, the Repower EU communication set it at the level of 13%. What other elements are needed highlighting in this revision? A new article dedicated to energy efficiency first principle. So it's a kind of policy principle that was guiding clean energy policies since the beginning, that first we need to reduce the demand and only then think about how to decarbonize the remaining needed supply. But this principle needs to be really put into practice, because very often we do not see that it is applicable. So that's why Article 3 of the recast directive will focus on how to put this into investment and decision-making practice, that energy efficiency is considered on equal footing as the supply measures. So instead of investing in generation or transmission capacities, how to reduce on the demand side, or to do an action on the demand side that will be equivalent and produce the same effect. Another very important element of the revision on which I will focus today is the strengthened energy savings obligation. So Article 8 of the recast directive, that is replacing current Article 7, and the rate of annual savings is set at the level of 1.5% per year in end-use energy savings, and this is for the obligation period from 2024 to 2030. But also that's one obligation period, but also post 2030, another 10 years obligation period. The Commission proposal is setting the same rate of savings, so 1.5% of annual end-use energy savings that will be calculated in the cumulative manner across the whole period, and also specific focus of realizing these energy savings specifically among energy poor households, so to tackle in addition the problem of energy poverty, which is very urgent now in the context of volatile and high energy prices. So that's about Article 3. Sorry, I'm just checking the chat at the same time. And indeed, I see a reference from Jean-Sébastien to yesterday Green Deal industrial plan. And I'm sorry, I didn't develop any slide about it, but it's important to mention that we have, in addition, of course, focus on competitiveness now, because energy prices are a challenge for our industries, are the challenge of for our economies, and that's why indeed the Commission issued yesterday a communication, Green Deal Industrial Plan for a Net Zero Age, where there is some focus, of course, on energy efficiency skills, with a specific attention to the industrial sectors and how to maintain the competitiveness despite the volatile and high prices, and how to benefit and take advantage of the transition to net zero, and bring these business opportunities to the EU. That would be maybe in the context setting, and sorry that I didn't mention it. Coming back to the EED, another important element is focus on public sector, with a new chapter containing 3 articles and a new target for public sector. Actually, public sector is focus is included in that Article 5, 6, and 7. Article 5 is setting an overarching target for the public sector to reduce final energy consumption per 3% per year. No, sorry, 1.7% per year. Then Article 6 is about public buildings renovation, setting the rate of renovation of 3% per year of useful floor area, as it is indicated on the slide. And then Article 7 is focusing on energy efficiency in public procurement, so how to put energy efficiency first principle into public procurement practice, and how to use really the criteria of energy efficiency in tenders in public procurement. And finally, another element that I need to highlight in the revised directive is the progressive approach of decarbonization of district heating and cooling. Efficient district heating and cooling definition foresee progressive phasing out of fossil fuels, and including the share of renewables. And this is in line with renewables directive. So the definition of efficient district heating and cooling is evolving until the full decarbonization by 2050. And these steps are described in Article 24. Okay, the next slide, please. So regarding the targets, I don't know if I need to stop very long here, because what is important to highlight is that the EU level targets is proposed to be binding for both primary and final energy consumption. As said, it was increased in repower to 13%. It is based on reference scenario 2020. So that's why you have different numbering than in the current EED that is in force. That's why we are at 9 or 13% comparing to the current 32.5. But it's not the same reference scenario. We are not comparing the same baseline. And why the baseline was changed? Because basically we need to take into account how the world has changed since 2007. It has changed significantly, and there was much progress done in energy efficiency, and that's why we need to base ourselves on a baseline that is more recent. And there is also a new definition of primary and final energy consumption and methodology of calculating it, but this is really linked to the macroeconomic statistic that is excluding ambient heat, including international aviation. So yeah, it's not fully comparable, the numbers between the current and the future directive, but it is because of the change of statistics methodology. The next slide, please. Yes, this one is focusing on Article 8, so the one that is talking about energy savings obligation. As said, the target, the rate of savings, of annual savings, is set at 1.5% from 2024 to 2030. What is very important to highlight is that in Annex 5, the proposal is not to count fossil savings coming from direct fossil fuel combustion technologies. This is fully in line with the overall, spirit of decarbonization, and the fact that we need to stop subsidizing fossil fuels at some point. So all these measures that member states will be putting in place to fulfill the requirement of Article 8 should be investing in forward-looking clean technologies and not into stranded assets, and that's why no more investments in fossil fuels technologies, even though they would be maybe more efficient. But as said, it creates a lock-in effect, and we are looking at a long-term horizon. So no more investment should be done in fossil fuels, especially in the current context when the prices are very volatile and very high. And the third element, just transition. So as said, focus on vulnerable consumers, realizing this share of savings among energy poor households. The next slide, please. This is very important for the discussion today, and for which the project can provide very substantial help, is how to demonstrate energy savings that are resulting from the measures implemented by member states. So we need to have materiality link that is strong, and member states shall demonstrate that the policy measure that has been implemented was implemented for the purpose of fulfilling energy savings obligation and achieving the end-use savings. So there must be a link between the measure and the savings that are reported under the measure. And there must be an evidence that is provided and documentation that energy savings are caused by the policy measure. And energy savings, as you know already from the current directive, can be metered, but if this is too complex, it can be estimated. So we are talking about team savings, and this is, I understand, the subject of your your project. They can be scaled or they can be surveyed in different contexts of different measures. Different methods can be used. Of course, metered savings, so the actual savings would be the best, but it's not always cost effective, it's not always possible, and that's why we need to have solid methodologies to estimate savings. Measures promoting, another element that is important in Article 8 is additionality principle. So means that these savings happen in addition to what would have happened in any case. So if there are other policy measures like, for example, ETS or taxation that are producing any energy savings, but that are not specifically designed for Article 8, those should not be counted under Article 8. So we need to make the distinction of what would have happened in any case, because that's the regulation, because that's the law, and what is additionally triggered by the dedicated measure that the member state put in place to fulfill the obligation of Article 8. And that's the additionality principle. But at the same time, we say that, for example, this energy efficiency investments in public sector to fulfill targets of Article 5 or requirements of Article 6, they can be counted, and they are additional. So those are not, let's say, excluded from Article 8. The next slide, please. I think that I already said that we need indeed to demonstrate the link, the materiality link, and for that monitoring and verification is very important. So clearly the legislative text says now that there is a clarification that monitoring and verification system must ensure that only end user energy savings will be counted under Article 8. Some member states implement Article 8 through alternative measures, and this is even more challenging to establish the link between the measure and the savings that are estimated. And that's why methods, measurement, and control and verification systems are even of more importance there. And regarding energy efficiency obligation schemes, member states should ensure that only energy savings from policy measures and implemented under Article 8 are taken into account, and we do not count those that would have happened in any case because they were triggered by other measures, for example, EU ETS or any other measure that is already in place and that would generate the savings. Okay, the next slide, please. Then we can move, I think, yes, there is one slide about industry and energy audits, because we are here today talking about motors and industry-related measures. And that's why just to recall that regarding industrial sectors, there is a change in the revised directive. And the approach to energy audits will be different because the obligation will be set according to the energy consumption, annual energy consumption, both for the audits and for the, putting in place energy management systems. So for the audits, the threshold is proposed at the level of 10 terajoules of annual energy consumption. And these will be the companies that will be obliged to undergo energy audits every 4 years. And the energy consumers that are above 100 terajoules per year will be obliged to put in place energy management systems. So there is a difference because currently there was, as you probably know, a distinction between large companies and SMEs. And in the future, this is not anymore the case, but it is really linked to the level of energy consumption. There is also in Article 11 focus on data centers, which will need to start monitoring and reporting on their annual energy consumption according to the provisions. And also in Article 24, there is some focus on data centers in order to recover waste heat from the larger significant data centers and possibly assess the feasibility to reinjection of waste heat to district heating. The next slide, please. And now finally, I will focus on the provisions that are looking at energy performance contracting and energy services, because indeed there is Article 27 replacing current Article 18 that is putting focus on this market development. Where member states should do 4 types of actions according to the requirements of the EED. First, they need to ensure that the contractual side contractual framework exists for market actors to use it, to have facility, to have template contracts and closures. The other layer is financial layer, so ensure that there are already dedicated financial instruments that can serve market actors, ESCOs, to refinance their business, develop their business. The member states shall promote also certification and qualification for service providers. So this is also linked to Article 26 about qualification and certification schemes. And finally, relevant for discussion today, monitoring and verification methodologies. there are harmonized, standardized monitoring and verification methodologies. This is super important, that this builds trust on the market, and if you have the right methods, this helps indeed the market to develop. Moreover, member states shall support energy service market by providing information, removing barriers, creating one-stop shops, so linking the demand and the supply side by providing all these accompanying measures and technical assistance. Finally, member states shall encourage quality labels based on European and international standards, so that the qualified service providers are available on the market and that the consumer can recognize them easily, because there are quality labels that that exist. The next slide, please. And I think that's the last one. Article 27 is also putting much of focus on public sector, because there is where the Commission see we could promote especially energy performance contracting, because there is kind of dual benefit. On the one hand, public sector has a great potential for energy efficiency. On the other hand, this potential is not used enough. On the other hand, this would release public financing if some investments in energy efficiency could be taken by the private sector, and that's why this public-private partnership, which is materialized by energy performance contracting, it provides this mutual benefit of, on the one hand, market development, on the other, releasing public financing. And that's why, for example, the EED recast proposes for the renovation of large non-residential buildings for the public bodies to assess the feasibility of using energy performance contracting. So it is not an obligation, but they must assess, and there must be some procedures for public procurers, for public bodies, when they envisage renovation of large non-residential buildings, that they take into account if this could be done using energy performance contracting. And the advisory role, one-stop shops, about which I already said. So I think this is everything that I had in my presentation. Thank you very much for the attention, and happy to discuss further.
This was really impressive, Marco. Thanks a lot. And indeed, looking at the number of legislative initiatives, together with all the ongoing discussions to cope with the current crisis, with the trilogues going on the EED, I'm really sure that we can be extremely grateful to for having you in our webinar in these busy days today. So thanks a lot. Okay, so our next speaker then is Zhao Feng from the Institute of Systems and Robotics at the University of Coimbra, also a consortium partner of streamSAVE. And Zhao will illustrate to you the guidance and the training module that was developed in a project with a focus on one of the energy saving actions, mainly motor replacement. Zhao.
So thank you, Didier. Hello to everyone attending this webinar. Let me just here share my screen. So today I will be giving you an overview of this how to use these calculation methodologies that were developed within the streamSAVE project. So I will be focusing on the methodology developed for electric motor replacement. I will begin by giving an overview of why this was considered a priority action. So why is motor replacement relevant? And then I will go into how to use the platform and to calculate the energy savings for this specific action, so electric motors. So electric motors have been a topic of discussion. The energy efficiency of electric motors have been a topic of discussion for a long time. So, but I think it is still relevant. So here we can see the data from the International Energy Agency on the worldwide electricity use. And we can see that particularly in motors, electric motors represent around 70% of the electricity consumed in this sector industry. And in commercial and public services, it would be of around 40%. So a very large electricity consumption, which means that even a small improvement in efficiency then translates into very large energy savings. So in Europe, we have had a regulation on the energy efficiency of motors for a long time now. So similar to other countries, we have started by introducing a minimum efficiency requirement at IE2 level. So motors can be classified according to their energy efficiency into classes. So IE1 would be the lowest class. We have IE0 below that, which is non-standard, but then and up to IE5, which will be the highest class. And now since 2017, all motors between 0.75 kilowatts and 375 kilowatts, which covers most of the motors, at least in industrial applications, must now be sold at the IE3 level. And from July 2023, motors with an output of 75 to 200 kilowatts must meet IE4 level. This is the first time that regulation at this highest level was introduced worldwide. So Europe is leading now in this the regulation of motors, the efficiency of motors. So if we have this regulation, so all new motors must be already at a fairly efficient level. Why is this still an issue? Well, motor lifetime motors have a very long lifetime. So previous studies have normally assumed that the lifetime of motors is between 12 and 20 years. So according to their power rating, so smaller motors having a lower number of years of lifetime, and then higher powered motors remaining in operation for a longer time. But still, this is a very large lifetime. So it means that motors, old motors, inefficient motors remain in operation for a long time. But then recent studies have, field assessment studies have shown that motors remain in operation for much longer than this expected lifetime. So a study in Switzerland, as you can see in this figure, showed that 56% of all motors in operation were much higher ages than was expected. And an even more recent study in the US has shown basically the same thing. We can see here that a lot of the motors remain in operation for much longer than 20 years. We can see this last bar, which is unable to collect. So this means that motors that where the nameplate was legible, or that the staff of the plants where the motors were in operation didn't remember when the motor was the age of the motor. So it means that they are fairly old as well. And so we can see that even when taking the usual assumed values for lifetime of motors, because they have a very long lifetime, even after the regulation is in place. Over 70% of the motors are still under the IE2 efficiency level, and around 40% below that, so below IE1. So very old and inefficient motors. So replacing these motors that are IE2 class or below, and this is a rough estimate. So considering an average 4% gain in efficiency, would trigger savings of around 25 terawatt-hours per year in the EU27. But this is just by replacing the motor alone. So when at the time of the replacement, there was a technical assessment carried out, and then you also corrected the size of the motor, because most motors are also oversized or can be oversized. So you can also do other system improvements. So equipping the motor with a variable speed drive, applying digital technologies, so sensorization for monitoring, and also larger system improvements to the system itself and the user equipment, because motors always are used to drive other equipment, so pumps, fans, compressors, conveyors, machines, things like that. So the total savings here would be over 100 terawatts-hour per year. So we can see that this would be a very good, a large contribution to the targets that were presented in this last presentation. So very relevant to still address motors, both in industry and in the service sector. So corroborating this, the International Energy Agency Net Zero by 2050 roadmap, so they identified 40 measures that would contribute to having a net zero economy by 2050. And one of these measures was that all industrial electric motors are best in class by 2035. So there is a need for the anticipated replacement of motors, which means that replacing the motor even if it is still working. So this is why we developed this methodology within the streamSAVE project. So it calculates a saving by replacing existing motors before the end of their lifetimes. So it also gives an estimation of the savings if you install a variable speed drive in applications that could benefit from it. And it can be used for motors under the motors in the scope of the eco design regulation. So the formula used for the calculation of the final energy savings is fairly simple. So you just multiply the number of replaced motors by their power, then by the annual operating hours, the differences in efficiencies between the existing motor and the higher efficiency motor, then the load factor they are working with. And for the calculation of the additional savings by using a VSD, we'll then multiply it by a factor that accounts for these additional savings, depending on the end use. So you can make the calculation using an Excel sheet, but also you can do it online in the streamSAVE platform. So here you have to input some data. So what are the conversion factors you are using here for the energy conversion factors and also the emissions factor? So you can calculate it using the EU values or the national values of your member state if you know what they are. And then you just introduce the power range of the motor this is all done by using drop-down menus, the efficiency of the new motor, and the sector you're using it in. And here within industry, we would have the usage of the motor also. So the number of shifts and number of days a week that it is used. So this is used to estimate to calculate the number of annual operating hours. And then if you are also installing a VSD, and what is the end use? So when you input these values here, then it would go and get values for the average efficiency of the existing motor and of the new motor. We consider that an old motor would have an average efficiency between IE1 and IE2. And then the number of annual operating hours, depending on the number of shifts that you are using. And here for the factor also for the VSD additional savings. So also depending on the end use application, you would get different factors. So after you input it, and you have to input the share of energy carriers. The platform is the same for all the, or similar for all the priority actions. But here in the electric motors, you just uses electricity, so it's 100% use of electricity before and after implementation. And then here you would get the gray cells that are filled in automatically. And then you have to fill in the number of hours, the number of motors that are replaced and their power, the nameplate power. And on the left column, where you, under national data, if you have values that are more accurate than the ones that we provide in the indicative values. So if you have measured or you have measured, for instance, the number of operating hours per year, or if you have, if you know the real efficiency of the motor that was installed, you can fill it in here, and then it would give a more accurate calculation result. So you just then press calculate, and it would give the results for total final energy savings, also the effect on for Article 3, and also the emissions, the primary energy saved, and also the greenhouse gases emissions savings. So you can then download the empty Excel file if you want to use it for your own calculations, and you can download the results inserted in the Excel file. There's also a practical guidance document that guides you through these steps, and also shows how these indicative values have been sourced. And you can also give feedback on the methodology, what improvements you think would be useful, things like that. So we have also, as Nella said, developed these methodologies for all the other priority actions. It's 10 overall. But that they work in a similar platform and in a similar way, and it can help to estimate savings in a very fast and simple way, we hope. So thank you. If you have any questions, you can forward them to me or ask them here.
Yeah, thank you very much, João. I've seen those numbers a few times now, and I'm still impressed about the scale of the savings that can be achieved. Indeed, there were some questions for clarification that I would like to take immediately now, because it's now maybe fresh in your head. Very interesting question asked by Jean-Sébastien about effect additionality. So Jean-Sébastien likes to know the potential of the 100 terawatt hours of energy savings. How much of those would be eligible to Article 7 EED? Because, oh, it jumps back. Having in mind that probably most of these savings will be related to eco-design regulation of electric motors, I guess, says Jean-Sébastien.
So here we have a question that the thing is that this, if you replace the motor before the end of their lifetime, this is not a realized sale under the eco design, so this would not be a motor that would be, although it is regulated, it is a regulated sale, so you can only sell IE3 motors within Europe. This would be a motor that would not have been sold without this measure, so it could be considered, I think, an additional to the eco design regulation, because it is an anticipated replacement.
Yeah. So bottom line, the 100 terawatt hours is additional to what has been calculated under eco design. That's
some of it, at least.
Yeah. Okay. Great. And then two more technical questions. Very briefly, Zhao, can you elaborate more in correct sizing of a motor? What would that be?
Well, normally for engineering purposes, because equipment in industries have to work all the time. Normally, they are oversized so that they can operate at all times without interruption, so in any situation. And maybe sometimes they are only used in that situation for a very low number of hours. But engineers tend to sometimes exaggerate on this safety factor. So normally we see that we have overpowered motors for that application, and motors operating in at a very low load factor have lower efficiencies. So if you correct the size of the motor, so if you use a correctly sized motor for that application, normally working at a load factor of around 60 to 75%, that would be the optimum efficiency of the motor, then you would get a saving there. So it should be estimated at around, well, some studies say 5%, I would say a little bit less, but around that. So it's not insignificant. Okay,
thanks a lot. And then maybe more a suggestion than a question. Is the methodology also applicable to transformers? Is the platform adapted, changing the relevant parameters? I think not yet, but is this an idea, Zhao?
I'm not sure, but I think that I think that the methodology could be applied, but not in this platform. But the same formula, more or less, could be used for transformers. Yes.
Okay.
And the rationale behind this would be applicable to this type of products, because yes, they have very long lifetimes, and the same would be also for example, pumps and ventilation, also because fans, because there have been also large improvement in efficiency in new products within the last decade, let's say, or even more. But because of their very long lifetime, these old inefficient products are still in use. So.
Okay, great. Thanks a lot. By the way, Massimo, thanks a lot for this suggestion / question. I can be in contact with you after this webinar, because I know that the Copper Alliance has done quite some work on transformers as well. So if you might be interested, I can contact you afterwards. Okay, questions keep coming in, but let's keep them for after our final presentation. So thanks, Zhao, and let me now introduce you to Rüdiger Lohse, who is Managing Director of DENEF EDL Hub. And EDL Hub is well, what's in the name, a hub of pioneering companies in the energy services industry, where they come together to network and collaborate to achieving the energy transition goals and to advance decarbonization. That's how they present themselves on their website. This hub was founded back in 2019 by the German Industry Initiative for Energy Efficiency, DENEF. So Rüdiger, I'm looking forward to your presentation.
Well, thank you. Thank you, Didier. And to just manage your expectations, I will not present much numbers. I will not help you very much with dedicated information on the sizing of energy efficiency measures, but I will look from maybe 500 meters from above on how ESCOs can solve the energy crisis, at least in Germany, maybe. So where we have a quite good insight. Thank you also for the kind introduction from your side, Didier. So let's start. I think we're still already quite consumed a lot of time. So I try to keep it short, just to give you an insight of the ESCO market in Germany, especially. It's growing steadily, 3 or 5% per year. Reason is, of course, in the recent year, 2022, the energy crisis caused by the attack from Russia on Ukraine. So what we see here is we have the potential of 60 to 80 billion per year of investments in energy efficiency in both industry and buildings. Where we are currently is around 10, so we are hovering around there. So, and there's a couple of reasons for that. We'll just give you an insight. And also what I could tell you, I'll give you a brief hint on something we developed. I just inserted this into the presentation. As I heard Zhao speaking, which I found also quite interesting because he was focusing on some stuff we also did. And I just want to give you a hint on the finance platform as well. So you will see a couple of things, how ESCO market is going, and you will have a kind of introduction on how ESCOs could contribute to decarbonize industry, especially. I would not like to talk too much about buildings, but just give you an insight, because what right now has happened is that we have a quite ambitious framework. It's more or less all the same in different, or at least in industrial or deeply industrialized countries in the European Union. And I think what Margot has presented is quite good as an overview of current status up to the future status. So we also expect very much, or hope very much, that those targets which Margaret has presented on the EED will really take place and will be in place sooner than later. So what the current framework for ESCOs in Germany is here the Energy Efficiency Act. We're close to a kind of, let's say, punishment from European Commission, because in the past 6-7 years, Germany was able to just postpone and postpone again the creation of an Energy Efficiency Act, which has now been put in place, or it's on the way, let's say, put it this way. We expect it coming up in March. And the Energy Efficiency Act is, of course, very important, especially to the ESCO market, because it should create a kind of level playing field. So what you see in most of European countries, that the request from European Commission to have a kind of a level playing field for ESCOs in legislation, also in grant programs, is still not the case. So it's really important that this now is coming from the German government, and it looks quite good so far. So the first ambition is there to have a level playing field for ESCOs. That means if a customer of an ESCO is requesting grant programs or is requesting a certain legislation way to be handled, let's say in the context of taxes or avoidance of taxes or whatsoever, we need a kind of a solid framework which defines targets, so overarching targets of energy efficiency in industry and buildings and in services, and creates also a solid role of the ESCO market. So this is on its way, but we hadn't had this in our legislation in the past few years, which had created some negative impacts on our market. So Energy and Buildings Act, I would not like to emphasize this too much, but of course it's important. It's 40% of the carbon emissions in Germany. So of course this is very important for the ESCO market to develop, and we are here moving into something which has not been the case in past 20 years, because gas was so cheap and everything was so nice. So now this has changed dramatically. And we see a strong move, not only in the buildings, but also in industry, into legislation which tells us to electrify heating systems, steam systems, and so on. So that means that you can consider either steam boilers or heat pumps, high temperature heat pumps and stuff like this. And this, of course, is a huge challenge for the industry from the perspective of consumer, but also for ESCOs providing those services, because they have not much experience which they could have gathered in the past 10 years or so. So this is quite new, and it's you can say it's kind of disruptive process. You can even call it, as we had it yesterday in a large meeting with the Department of Energy, it's somehow quite a revolution, because we move from a total dependency of natural gas into electrification of more or less all the most important heating processes. So in addition to that, under the frame of an Energy Efficiency Act, which may come into place by March this year, we have the Heating Design Act, which from 2024 on obliges building owners, but also to a certain extent commercial building owners. So that means services, shops, and stuff like that, to move from gas or oil-fired fossil-based heating systems into renewables. So that's also a huge market. Well, it's quite new, not much experience there, because as you know, I need not explain, ESCO are responsible for the targets they promise to their customers. So that means you cannot just deliver a heat pump and say goodbye building owner or goodbye industry. It's going different ways. So either the remuneration system is depending on the energy savings you achieve actually, or in the other case, you have a kind of guaranteed efficiency, which is measured year from year. So what is important here is a kind of track record, which each ESCO needs now to collect very quickly to get the significant experience which is relevant to create such risk-based business model like ESCO business model are usually. So that is something which is going on, you can say, since summer last year. So what we see right now, we have a couple of new business models, especially also in industry. So in the industry, we see maybe and it's quite a good practice, I think. So we have a kind of grant program which provides support, significant financial support for industry companies, which try to decarbonize their processes, but also their total industry plans or several industry plans in Germany and outside Germany with the help of these EEW grant program. And the first step to take is, of course, here to set up a transformation agenda. That means a transformation agenda tells us, okay, which measures you need to take to end up with a carbon neutral process by 2030 or 2045, and which steps are necessary, which technologies need to be implemented, of course, with a performance guarantee. That's the specific case here. When ESCO is providing that. And then also, how do you finance that? On balance, off balance, very important question in industry as well. So is somebody taking the risk? Is there liability to provide those payments to an ESCO, or is it a kind of pay-as-you-save contract, which is usually an ENPC? By the way, ENPC classically is not working very good in industry due to changes of operations, maybe from monthly base. So I think it's quite important to see that a strategic approach is now the choice of the moment in the industry. So we see that a lot of those transformation plans or transformation agendas are prepared to start into the investment by the end of 2023. So that's something where ESCOs are heavily involved. So they learned that it's a good idea to provide those transformation plans and then go hand in hand in a partnership with the industry company to the way into the decarbonization. So I think it's quite a challenge, and typical ESCO models have been totally reversed in the past 6 or 7 months. So it's quite interesting, or I think fascinating, to be a part of that and to go with the ESCOs this way, support the ESCOs in that way, that they are successful and able to provide their services in a proper way. So just a small insert, which I just made when João was presented, I just wanted to, and we see some of the discussion going, how can we provide a kind of due diligence on those different technologies implemented in industry. We had some very simple ideas when we set up in the past 2 years within the German national project funded by Department of Energy in Berlin to set up a first finance platform for energy efficiency investments in SMEs. It's called finvest.de. You should not be surprised. It's in this case all German, but it's not much words. It's very clear. It's a straight way forward. And we see something which João has presented just in his slides. So it's a kind of very straightforward and very simple due diligence for different technologies, which are mostly representative in 90% of industry. That means ventilation system, lighting systems, pumps, motors, whatever you name it. I think João had put it in his slide quite well. So that's something where we also had this point where banks need to understand the risk of such kind of investments. And we made such kind of very easy approach based on the eco-design target values for those components, and then provide the due diligence based on that. So please hurry up. We are handing this over to a venture builder in the next 2 weeks. So if somebody wants to look into that before it disappears for 1 or 2 weeks, you should look into the finvest.de how kind of simple due diligence for energy efficiency measures could be provided. So who is with us? We have with our members about 70% of those 10 billions of annual return in the ESCO business with our companies. So they are heavily engaged, of course, right now when the business models are changing. So you have here typical utility-based business models represented, but you also have here at least 3 ENPC providers, so energy performance contracting providers, which are quite successful in the building sector, but are very careful to make performance promises in the industry due to, as I mentioned already, due to changes in the operational plans. It's not a very easy thing to go to provide a pure and transparent calculation of the savings and the proof of evidence for those savings. But as we learned, it's interesting for industry anyway that somebody takes care about energy efficiency and looks at it in a certain range of ±5%, and that makes the contract for ENPCs much simpler and not so risky and not so aligned with so much work for legal services with that. So it's much more appreciated by industry if you make it simpler. So what we do, I just flopped this, but just what we do in this case, and where I would like to highlight in my last 2 slides, what we're actually doing and where we see the mega trends in the ESCO business here in Germany, at least. What we do is to provide support on this transition ways from natural gas-based business models, ENPC models, also based more or less on heating systems, which are based and fired with fossil fuels, towards a more electrified heating system and steam system. So that's something we do very heavily with our ESCOs, which are operating in the industry sector. So what does this mean? We want to provide solutions for the policy demands and the requirements and the policy framework which Germany is exposing to the country. So that means we need to have, of course, a kind of mainstream for climate protection, but we need to have decarbonization 2045, of course, that's clear. But the current challenge is to provide 65% of renewable energy in the heating market, which means basically, because we have not much wood chips or biomass other ways, which means basically to have a kind of renewable power system based heating system. And of course, we need to have a kind of system which provides the most support for the worst performing buildings. So that's something which describes our framework quite well. And what that means is to move ESCOs and the whole ESCO business from something which was on maybe only a heating system or other detailed measures into a holistic approach. That's something which takes place right now within transformation plans, within investment plans which we set up for the industry especially, but also for real estate companies, and where our ESCO companies provide a good service in this kind of holistic approaches, from consultancy to design, to the implementation, to the finance, and then, of course, to the monitoring and verification, which is then in place for 5 or 10 or 15 years. And what we see there as kind of technical trends, to just give you insight, what are the main topics right now. The housing sector means that we have typical system with natural gas-based CHPs and a gas peak boiler, which is replaced right now. You see this in the middle with exploding gas and power prices, with renewable energy-based power and heat pump system. And in industry, especially with not much experience so far with high temperature heat pump systems, which move up to 100 degrees and more, of course, aligned with a performance guarantee. And this is so far still a challenge, because if you need to provide a guarantee, it's a different game. So also we see a large move into the storage, electrical power storage, but also thermal storage, or of course chiller storages. So that's something which is quite new in this business of the ESCOs in industry especially. And what we see there is a very quick development in holistic systems to manage those storage, energy production, and energy consumption system. That's really moving quite well. So that the ESCO is able to provide a performance guarantee and also a kind of supply guarantee for certain processes, and is able to moderate and mitigate those load curves, especially when it comes to natural gas, which is in some processes still needed. And if it comes to power, which is also a very important issue, because we are back to those times when we have high peak electric peak power prices, where we are around €1,000 per megawatt hour. This has not been the place in the past 12 months, but it has come, or it had come back in August last year. So that forces industry to just mitigate their load curves, especially in energy intensive industries. So that's what we can offer in a very quick glance. I think in the next 2 months we will have the first experience reports from especially energy intensive industry, because then the first project have passed the 1 year mark. And as you know, especially in energy performance contracts, you can see then how the assumed performance was, or how the performance guarantee was noted down, or was paragraphed, and what really came out of that. So it's quite interesting. So I hope to be able to provide some serious reports on the outcomes of those energy performance contracts in the industry under the new framework, not later by May this year. So thank you very much.
Okay, thanks. Thanks a lot, Rüdiger, for again a very interesting and extensive presentation. Let me immediately hand over to Nele again. Nele, I see we have only 5 minutes left for a discussion, but I'm sure that you will manage in guiding this into a very topical one. So
Yeah. Thank you, Rüdiger.
Meanwhile, can I invite Zhao and Margot back on stage as well? So if you could switch on your cameras again, thanks. Yeah, great.
Yeah, first, thank you for the presentations. Maybe first a question to Rüdiger, as it links to the presentation he just gave. There is a question from Rita Werle about, how can ESCOs provide support in relation to, the question is, to what extent can motors, so industrial motors and motor systems in industry, how can they be included in the ESCO portfolio, or what are the challenges, or is it, or maybe it is well included? Can you give some insights on that?
Yeah, sure. I'll try to keep it brief. Basically, they are included, but not in performance guarantees in a larger extent so far. Because what you can see in industry is that these are, you see, very close relationship, and the risk, not especially from motors, but usually ESCOs try to have a holistic view on all the processes, not only the motor, but also the processes aligned with the motor. So I think this is the way they look at it. So it provides certain levels of risks. And if you set up such kind of contract, the first year of this contract will never be a kind of EMPC, because you do not know how the operation schedule of an industry, of a process may change, and which kind of impact it may have on the motor, on the energy consumption of the motor, on the processes aligned with the motor. So typically, if you look into a plastic industry, when they have large motors and ventilation system to provide those kinds of layers. So that's a typical case which I have in mind from my own experience. We would like to start with a kind of supply contract, learn about that, about the process, and then go into the performance risk of an EPC. But so far, motors are not high investive pieces, so they are not considered as a very high risk. But so they are, they are picked up within the process. So the more interesting pieces of that cake are, the deeper you get into the processes, the more interesting it gets.
Thanks for the clarification, and good that it is indeed included while having still some challenges. Maybe a next question to Margot, as you indicated in your presentation, also about the importance of monitoring and verification methods that could be provided by member states in relation to support the energy services market. StreamSAVE is developing deemed savings methodologies. In these days, the ESCO market is perceived as a quite fragmented market, in the sense of not the same across all countries, but can streamlining the deemed saving methods also help ESCOs in reducing the risk, in the sense of risk of variation across countries, or making it more easy in understanding the savings opportunities. Or how do you consider the importance of those methods related to the monitoring and verification in general?
Yes, thank you. I think especially in application to the industrial sector, deemed savings can be close to accurate savings, because the behavioral factor is not that important, I would say. I mean, if we are talking about exchange of motor by a more efficient one, the behavioral aspect do not play that much as it would be in the building sector, right? So indeed, these methods, if they can be promoted across member states to provide kind of harmonized basis, will certainly help ESCO models to develop for industrial applications, for investments in energy efficiency industry, as this will also help ex ante to estimate what is the potential for the business, for the savings. So yeah, for the ESCO to make a business from the investment. And then indeed, it could be easily scaled up across different industrial sites in different member states. So in these specific applications of industrial facilities, I think deemed savings are a good solution for standardization of of the approaches. Thank you.
Yeah, thank you. Yeah, and there are much more questions in the Q&A. I can't ask them all, so maybe just one final question also to João about how there's a question on how the measurements can be done while the motor is running in the industry without stopping the process. And maybe also a second question is if you have also any indication of other industrial actions which might be in need of deemed saving methods and where ESCOs could be supportive as well. So maybe first the question on how to measure and the savings of a motor while it is still running and not stopping the process. I don't know if it is possible to clarify or not. You are still muted.
There are some methods, but I don't think they are very accurate. I'm not aware of any type of portable dynamometer to directly measure torque in motors in the field, so without disconnecting the motor from the end use. But I'm not sure if there exists, so no help there.
Yeah, and maybe then the second question is then, can you give any indication of other industrial actions or appliances that could also benefit from deemed savings and where ESCOs can play an important role? I think you...
But there was also some comments here that deemed savings could not be very useful for this industrial process, and I tend to agree with it because at least for this measurement and verification actions, because there is a large variation in process. There can be a large variation between year-to-year production processes in industry, so it's difficult to really ascertain without doing a complete engineering assessment of the system, the actual system there. But I think it's more useful to understand what is the range of savings that we are talking about when we are considering doing this type of measures. So much like this example that Rüdiger just gave of the F-Invest, so if you want to just quickly check what can be the savings by doing one of these measures in industry, and I think then this applies for almost all the industrial equipment. So
okay, thank you for the clarification, and thanks to all presenters. I think this brings us also to the end of this interesting webinar, and it was good to hear that savings methodologies, but also target setting and putting a right framework in place is crucial in the development of the ESCO market, for which, and this was also illustrated by the example of water replacement. So thank you for your insights, and also thank you for your participation.
Thank you all. And I would suggest, because I see that there's a lot of discussion still ongoing, to keep in touch with the speakers. So whenever it considers the calculation methodologies on motors presented by Zhao, please reach out to Zhao. We can provide you with all the necessary details. And for all the rest, please, just drop us a line, send us an email as a reply to the mail that you will all get with the links to the recordings and the presentations, and we will try to follow up with you directly. So thanks a lot to everyone. Thanks to the speakers for your very interesting presentations, and thanks to the audience for being with us, and looking forward to a next occasion.
Thank you.
Yeah.
Goodbye.
Bye.